So let me see. Which one was that again? 23? Where are you at? There you are. Yeah, this is because part of the reasoning behind this problem is for you to identify that you cannot get the inverse of this directly. But something you can realize, the output, what is the output to this? All right, let me ask this way. What the hell is this asking you to do? It's asking you to find the value of the inverse at 2, but it's another way to look at it in terms of this. We can do this. We can do this. What is the answer? I don't freaking know. Let's call it y, because it's an output. Is that? It's actually x. It's an input. So what can I do to both sides to kill this? What's the opposite of that? By definition, we can do this. What does that symbol mean? What does this mean? Inverse of f of x. Is an inverse another word for opposite? So what is the opposite of f inverse? F. So what can I do to both sides to kill this? Take f of both sides. What would you do to solve this equation? What would you do to solve that? How would you solve that equation? Cube both sides. Why the hell would you cube both sides? Because it is the opposite of cube rooting something, right? So what do you do to kill a function that's there that you don't want there? You apply the opposite, the inverse. So let me apply f to both sides of this. Right? So 2 equals f of x. So what this is saying is, what does x have to be to make the output 2? I kind of love this problem, but it's also very evil, because you can't find the inverse. So you can't get the inverse and just plug 2 into it. Has anybody tried to find the inverse? If you found it, you messed up, because you can't. All right.
The answer is not 2, though.
Of course not.
Okay.
I didn't get to the answer, did I?
Okay.
I'm recasting what the question is.
Okay.
So if I write this, what's the question? What is x? What's the input have to be? This is a deeper idea of what inverse means. What does this represent physically? What does that represent physically? An angle. I love kick-ass. That's an angle. That is an angle. Why? Because it's saying, isn't this normally, so let's see. So cosine theta equals something. So theta equals the inverse cosine of something. There, inverse cosine is an angle. Because what is the input of a cosine? An angle. So what's the output of an inverse cosine? A freaking angle. Right? Because what inverse functions do? Switch x and y. Switch inputs and outputs. That's what they do. Okay. Now, this is slightly evil, because it is sort of guess and check. But it's not that evil when you realize, how often does natural log of something have a nice output? Huh?
Once.
Yeah, once really. The inputs have to be like e. What's the natural log of e? What's the natural log of e? 1. You saved your ass. What the hell? Natural logs. What are natural logs? What are logarithms? What are logarithms? What are they? Yes, beautiful. They're powers. So whenever you see a log problem, it's asking you what power do you need. So natural log of e, what's the base of ln? What's the base of ln? No, the base of log is 10. E. So what power does e need to become e? 1. Now stay with me now. This problem, I love this problem, but I understand why people would hate this problem. If I let x be e, this is going to be frickin' 2e. In fact, any e is going to make this weird shit. I'm never going to get a nice answer out, am I? What's the only place where ln has a nice input and output? You said there was one place, and you're right. 1. What's natural log of 1?
0.
Yes. Any log of 1 is 0, because what power do you need to raise anything to get it to be to 1? 0. What happens when you put a 1 in? This becomes 0 plus 2. We got a 2. There you go. The answer's 1. I gave it to you, but that's a weird one. I understand. But that's the kind of thought process you've got to put into it. And this is what you should be used to coming out of trigonometry and pre-calculus, is playing with shit, right? My students, when I teach them trigonometry and pre-calculus, they try to finally get over the fact that I keep saying play with it, right? You got to play with the math, and you're so not used to it. And now you should be, but I feel like maybe you're not as much as you should be. Like when you had to prove trig identities, didn't you have to play around with shit? Do you remember doing that? If you don't, that's a bad sign. Remember proving trig identities? Yeah. Yes. Didn't you have to pick a side, work it? Oh, that's not going anywhere. Let me pick the other. You had to play around with it. Try something. That didn't work. Let me try something else. You guys kind of a little bit? Oh, and you're all like, damn it, man, just tell me what to do. No, that's not how math works. It starts with pre-calculus and trig, where you go, oh, this is how math really is. I get some ideas, and I get to play around with them, see how I can use those ideas. Calculus, you got to be ready for that shit. Ideas, how do I play with those ideas? Right? Yeah. I love you guys. I can see in your face. You're like, just stop, Jeff. Just tell me what to put where. All right. That ain't going to work. Do I have any? Yes. Any other question from homework I can just riff on for a little? Yeah.
Just a general question. Do you want us to go out of our way to show work, even if it's not the kind of problem where I'm doing a lot of algebra, or?
Give me an example.
So for example, if it says to take log of.
Oh, I see. Yeah, you don't have to show a lot of work. So if I say what's log base 2 of 16, you can just tell me the answer.
Okay.
At this level, it's kind of like if I said 8 times 7 and somebody wrote 8 7s and added them up, I'd have to slap you. Right? I mean, come on. But this is now, on this level for Math 110 is this for us. You shouldn't have to show any work for this. Some of these questions you might have to do a little work for yourself. Right? What's log base 8 of 2? Oh. I think we did this problem, didn't we? Yeah. It's 1/3, but you might have to do some stuff, but if you just put the answer down, I can't really complain too much. Those are the nuts and bolts questions for this class. Yeah. Okay. Anything else general or specific about homework? Remembering that we have a quiz through 2-2 on Thursday.
Is the quiz going to have these word problems from 2.1 and stuff like that?
Word problems.
Yeah.
So what is a word problem? What is a word problem? I love you guys. A word problem is a problem where you have to create your own equation. The problems in 2-1 gave you equations. And I love it. You're all like, what an asshole. It's a word problem. It's got words in it. Screw you, Jeff. But I desperately want you to understand a real word problem is one where you have to actually create your own equation. And that was always the suckiest part. And then solving it should have been the easy part. That is not what these are. So let me do an example, because I think there's got to be more people that have questions about some of these problems in 2-1, and you're just not asking them, which doesn't make sense to me. Let's see. Where's the nifty one? Oh, all right. I think this is not necessarily one that I signed. Maybe, I can't remember. Number 5 and 2-1. This is a homework problem, then here you go. They give you the height in feet after t seconds is y equals 40t minus 16t squared. Already, it's not a word problem, because they gave you the formula you're going to have to use. They gave it to you. Find the average velocity for the time period. So here they say time period beginning at t equals 2 and lasting, if you've done this homework, this should sound familiar. It's 0.5 seconds, it says, for part 1. All right, now help me out. if I graph this thing, and I'm not going to, here's t, here's y. If I graph this thing, it's going to be a down parabola. I'm not even going to try to freaking figure out what the vertex is. If I graph that thing, right, and I find the slope somewhere of this thing, if I find the slope somewhere somehow magically, what would the units be on that? Because how do you find slope? What are the units of this axis? Sure, feet, right? Because it represents the idea of height, so it's feet. And what are the units of this axis? So if you find the slope, which is change in y over change in this case, t, what are the units going to be? Feet per second. So freaking velocity, right? That's what does slope mean? The rate of change of blank. And if I say the rate of change of height, it's another way to say speed or velocity, right? So like, dude, just say freaking speed. You guys with me? So when they say find the average velocity, find the average whatever rate of change, that just means find the slope. And how do you find the slope? Get 2 points, y2 minus y1, x2 minus x1. Right? So here, how do I, for this problem, does anybody see what the 2 points are going to be? What 2 points am I dealing with? Those are the inputs. So I'm dealing with a point 2, I don't know. Be careful. What's the next input? 2.5, because it lasts 0.5 starting here and lasting 0.5 seconds. So where's the thing at 2 seconds? And where's the thing at 2.5 seconds? And then I want to find the slope between those two, because that would be the average velocity. That's what slope means, rate of change of blank. So all the problems in section 2.1 boil down to, can you make a couple points? Find the slope. Can you make a couple points? Find the slope. 2.1 is trying to bridge what you know from algebra to what we're going to do in calculus. So 2.1 should be very algebraic feeling, because we haven't gotten into calculus yet at that point. So here, this would be, if I plug a 2 in, what do I get? Something, 16, maybe? Oh, shit. And if I plug a 2.5 in, I don't know what the hell you get. You get something. Nobody's going to help me. All right. Let's see. 0. 100. What is it?
0.
0? Really? 100. And then, yeah, that works. Okay. So then you just find the slope between those 2 points. Because what does the slope represent in this problem? Physically, what does the slope represent? Velocity. And that's what they're asking you for, find the average velocity. So you see that shit and you just say, oh, you mean find the slope. Let me find the points you're talking about. Get the slope, I'm done. Because this is something we should know from when we first learned slope. It means rate of change. And what's velocity? Rate of change of position. There you go. Maybe. Hello. How you guys feeling? I mean, that's a few problems are like this. Some problems don't give it to you like this, they just give you an interval. It's even nicer. They would have said, on the interval 2 to 2.5. I would have done the exact same work here. They just give me the time interval in a different way. That's all. They're not all different. They're all the same. Okay, maybe. Anything else from homework before we get into new stuff? Let's start you. Yeah, okay. Yes?
I wrote it down somewhere, but I can't find it. For the
You
quiz
did
on
what now?
Thursday.
Sorry?
I wrote it down somewhere, but I can't find it. For the quiz on Thursday, it's chapter 1 through 2.2.
Yes. Quiz Thursday, chapter 1 through 2.2. Exactly. Coolness.
I got one.
Yes.
For question 9, there was a part where we graph
Oh,
it.
yeah.
When we graph it.
Yes.
I don't know how to graph.
I don't know if you guys remember me talking about a nice function. Oh,
Yeah.
that's a nice function. Look at that thing. What was my example of an evil function?
The one that
Goes insane. That's this one. This one goes insane. Why is this nice? Because can't I kind of like pick 2 points really far apart and the slope is still pretty good? Approximation for the slope in the middle. I mean, do you guys see what I'm saying? It doesn't really change much. If I have one that's like this, and I pick the 2 points that are similarly spaced, it's going to be 0 there, for example. I mean, you'd have to, if I wanted to know the slope here, I'd have to get really close, because I just get a little further away, it looks like it's a zero slope. So I have to be really close. That is the whole idea behind number 9. Do they get close enough from what they ask you to do? That's the idea with number 9. That's a good note to take if you have not done number 9 on 2-1. So when you hit it, you go, oh, shit. That's the point behind this problem, is they didn't get close enough. Because here, if I stop right there, it looks like a zero slope. If I get closer, then I see that it's not really zero slope.
Well, it just said to graph it, and I didn't know how to graph it.
Oh,
Like, I didn't know if you wanted it all nice and neat, or if I could just,
oh, just see the little symbol next to it?
yeah.
Next to part B? That means do it on a graphic calculator.
Okay.
Yeah. Or Desmos or something. You can copy a sketch of it for me. It doesn't have to be pretty.
Okay.
But it's mostly for yourself so you can answer that question. So you see it going insane. Yeah. Yes?
I have a really rudimentary question. How do you identify which one is Y2 and which one is Y1?
Doesn't matter worth shit.
It doesn't?
Doesn't matter worth shit. Because watch this. You ready? So if I said this is 2, so that would be 16 minus 0 over 2 minus 2.5, right? Is that cool?
Mm-hmm.
Versus, I could have said it the other way.
Mm-hmm.
You see how they both come out the same? The bottom's negative here, the top's negative here. So as long as you are consistent with you don't switch this minus this and this minus this or something, as long as you go the same way, then everything's golden.
Matter.
That's the whole purpose for these stupid little subscripts in this thing, is just to make you sure that you go the same way. If you do this minus this, you better do this minus this. If you do this minus, you better do this minus. Just go the same way, or else you get the opposite sign of what it really is. That's it. That's all this shit means. There's no magic way to know that this is x2, y2. It doesn't matter. I like it. Maybe. Okay. That shouldn't be crazy news, but yeah, sometimes it gets a little confusing when you have something like this. You're like, well, how do I know which one? It doesn't matter. The whole purpose of that is just go the same way. Anything else from homework stuff, or just general stuff? All right. Okay. I think the last thing we did, let's do a couple reminder problems. Let's see here. Yeah, let me put this up here. Let's do an example of what we did last time, and then we'll get into some new stuff. Yeah, let's see that one. I like that one. Yeah, we'll do that one. All right, let's see. So if you have your book, I'm going to look at number 8. Somebody remind me, what's that little plus meaning right there?
Coming from the right side?
From the right, I like it. Okay, so it might be better to say it that way instead of from above and from below, because then people are thinking above, below, when really it's above, below. This is all about x down there, right? So look at the first one. It doesn't have a plus or a minus, so in order for that to exist, what's got to happen? Yeah, it's got to agree from both sides. Now, I'm doing the answer here, but as you approach -3, what's it doing from both sides? What are the outputs doing as you go towards -3? They're both going to positive infinity. That would be the answer. Now, that's a type of does not exist. Does the limit exist? No, because it goes to infinity, but you are a little more specific when you say positive infinity. How's that going? And now, if it would have went like this, what would the answer be? Does not exist, because then they don't even agree on which kind of infinity. Right? The one guy's like, I'm positive, screw it. There's just, you're not going to agree. I like it. There could be no peace in the Middle East. What about part B? go to 2, and this one says from the left. So as you approach 2, as the inputs approach 2, oh, hello. What are the outputs doing? Negative infinity. I love it. I love it. Is everybody able to look at that correctly? Because it's kind of like clicks in your head, because you keep looking at it wrong, and you're like, oh, that's the way to look at it. As you get closer to 2, what are the outputs doing? They are getting closer and closer to negative infinity. Yes?
So if there wasn't a minus sign on that 2, then there wouldn't be an answer?
What would the answer be if there wasn't a minus sign on the 2? Does not exist.
Does not exist.
Beautiful. I like it. And what about this guy? This is the same thing, and you're basically pointing out from above it's going to positive infinity, right? I like it. What about the limit as x goes to negative 1? Which one? Yeah, negative infinity. I love it. Kick ass. Kick ass. So there's some examples of infinite limits. They are a type that does not exist, but they're just a more specific type. What about, let's do one that's a little more finite. What's the limit as you let t go towards 0 from left? So as you go approach 0 from the left side, this is really strange, 2, 1, 0. Here. So as you approach 0 from the left side, what are the outputs doing?
Negative 1.
Negative 1. I love it. Right, going towards negative 1. Does it matter that that's filled in?
Yes.
No. For the limit. For this question, does it matter that it's filled in? No, it doesn't matter with shit. What's the limit as you go to 0 from above? So as you go towards 0, from the right, sorry, I always say above and below. As you go towards 0, what are the outputs doing? Going to negative 2, I love it. So of course the limit as t goes to 0 does not exist because they don't agree. You can't consolidate it into one answer because there's 2 possibilities, so there's just doesn't exist. What is g of 0? Negative 1. Then it matters. The function value, of course, cares where the hell it is because it's the whole thing it's about. Limits don't give a shit what happens there because they never get there. Who cares if it's open or closed? I like it. Okay, that's it. Then we did stuff like this, right? So what are the basic things you're going to have to be able to do? When I ask you to find a limit using algebra, I'm going to be very specific because I want to ask you, to find the limit using a table. So what does that mean? If I had a problem like, oh, I love that. You're looking this way. If I had a problem like this. Yeah. Limit as t goes to 0. What you got, Jeff? And I say use a table. What kind of table would you construct?
Above and below.
Yeah. So you would put, maybe I would put like 0 here, little parentheses. And what would these be? For example, what do you think?
-3, -2,
Yeah, what do you think about that?
-1.
That's the right idea, but those steps are humongous,
Yeah.
right? And you're still not very close at -1.
Right.
So maybe start at -1. And then negative 0.1 maybe. And then negative 0.01, right? And on the other side, we'll just mirror that. Okay, so you're gonna see, you hopefully have done some of those problems in the homework. So I'll be very specific. I'll say find the limit using a table, or I'll give you a problem like this, find the limit using algebra. When you see a radical, you're gonna think about using what? Conjugate, right? We'll talk about a conjugate. When you see polynomial, like x squared minus 4 over x minus 2, you're gonna think. All right, let me write down. So if I solve this, the limit is x goes to 2 of x squared minus 4 over x minus 2. First thing you should do is what? What do you do? Very first thing.
I know, like it in.
Plug in 2 to make sure there's a reason to worry about shit, right? So sure enough, when you plug a 2 in, you get 0 over 0. And what did we say that was?
Indeterminate.
Indeterminate. That means you got work to do. If it would have been this, I like this question. What would the answer be? Be more specific. Oh, I like that. Somebody perked up. I love it. This is like on the graph. What would it look like if you graphed it as you get close to 2? Yeah, good. Yeah, I like it. And so all you're doing is you're saying the wrong word then, but I want you to be sure. So it's going to look like as you approach 2, well, as you approach 2, what's going to happen? This is going to be negative over, it depends. Do you guys see that? Because this is 2 squared minus 5 is going to be negative 1. And if you're approaching from the left, this will be negative. If you're approaching from the right, this will be positive. So that is going to end up being like this. So then it does not exist. I like it. What if I said this? What's the top? At 2 or even just near 2, what's the top? What's the main thing you can tell me about the top? Near 2, what's the top? What kind of number is it? Negative. It's negative. Near 2, it's negative. What's the bottom going to? It's always positive, I agree, but what's it going to? As x goes to 2, what's this going towards? 0. So you get negative over getting really small. So what's the answer? What is something divided by a really small number? A really big number. So something divided by the absolute smallest number, infinity. But the top, remember, was what? Negative. So it's negative over 0, so that's going to be negative infinity. As you let this x get closer to 2, the bottom gets smaller and smaller and smaller. The top is negative all the time. Close to 2, it's negative all the time. So what's it going towards? Negative infinity. This is the kind of thing you have to do, that you have to figure this out. So going back to this one. So now that we know that it is indeterminate, that means I have work to do. That one, those were not indeterminate. I could just look at it and tell the answer. Here, of course, what would it do? Factor. I love it. So when you see polynomials, indeterminate form, you factor the shit out of them. Because what should happen is the problem should cancel. I like it. And the last type, we did one of these on the test, on the little handout we had last time. Let's see if I can make one up real quick. Sure. When you have fractions inside of fractions, the main thing you do is consolidate, just like we did on that sheet. I like it. So those are the 3 big ones. Conjugate, factor, consolidate fractions. Those are the kind of like the 3 big things that could happen for evaluating limits algebraically. I love it. Okay. So that gets us caught up to, yeah, this is a good one. I like this one. But let me show you something. Let me see if you guys know about absolute value as much as you should. I'm going to do the same kind of problem. Yeah. All right, so what do you guys think? How do you start to look at this problem? So what's the very first thing you do? I got a limit problem. I'm asking you to do it algebraically.
Just get rid of the absolute value.
How would you do that? What is the absolute value of x minus 2?
X minus 2.
Why can it not be that? What does it depend? Do you always do the same thing with absolute value? What's the absolute value of 7? Did you do anything to 7? No. What's the absolute value of negative 7? Did you do something to negative 7? Yes. So personally, I hate the absolute value function because it hides that it's not really one thing. It's two things. Do you guys know what the absolute value of x is? Let me write it like that. How about? It's two different things.
X or negative?
Yes. When is it just x? When does the absolute value not do shit? What kind of number would you put in? Yeah, or 0, right? When does the absolute value not do something? When does it just leave it alone? When it's already positive or 0, right? So if x is greater than or equal to 0, it leaves it alone. Now, if x is negative 7, what does it want to do to negative 7? It wants to make it positive. What do you do to make this positive? You multiply it by negative. So I'm going to multiply. If x is negative, people always look at this when I teach this in like 90, 110. They're like, well, that's negative. No, it isn't. It's negative times negative, which is freaking positive, right? And that's really what happens here, is that's the negative of that. It's the opposite of what it is. Okay. So what's the absolute value of x minus 2?
X plus 2?
No.
Negative x plus 2?
All right. It's negative x plus 2 if what? Oh, boy.
Less than 0.
Not 0 in this case. Why was it 0 over here? Because it's x minus 0 inside. So what's the point this is going to change around?
Less than 2.
2. It's going to be 2. So if x is less than 2, what kind of number is this? 1 minus 2. 0 minus 2. Those are all negative. That's why it changes. When is it going to stay the same if x is greater than or equal to 2? So this thing is two different things depending on which side you're coming from. You should already know the answer then. Right? If I'm coming from below, it's this. If I'm coming from from the left, it's this. If I'm coming from the right, it's this. So the answer is going to be different from both sides, which means the answer overall for this limit is does not exist. So if I'm going from, let me see. Let me make this a more interesting question. So if I said, what's the limit as x goes to 2 from the left of this, I could immediately rewrite the bottom as this, which is really negative x minus 2. Is that cool? And so what's this limit going to be? What can I do there? What is that? What is this? Yes, that's negative 1. So what if I said the limit as x goes to 2 from above? How can I rewrite the bottom now? From the right, sorry. Well, I can write it like that. Because it stays the same now. If I put a 3 in, a 2.1, those are positive. So it's just going to be the same. This limit is 1. So from the left, it goes to negative 1. And from the right, it goes to 1. Got it. So what's the limit there? It does not exist. I like it. So you will see a problem like that in the homework. Now you know how to tackle it. Okay, maybe. So calculus is so desperately not, here's an idea, here's a process, use it there. Here's a process you know. Calculus, and actually all of math is, here's an idea. There's a bunch of ways to use it. Here's another idea. There's a bunch of ways to use it. The better you understand the idea, the easier it is to handle all the different ways to work with it. So this is a very conceptual class. Yeah, there will be some just plug it in and do shit. Of course there will. But they're going to be built on ideas. The better you understand those ideas, the better you get what to do. Okay. So today... oh, you're going to love this. Okay. Sorry. Don't worry about that up there. I'll show you some pictures here in a minute. So the purpose of going over section 2.4, I keep using this idea of close. If I say that, you guys with me on that? I keep talking about you got to get really close. I want to let this get close. We keep talking about close, so we've got to come up with a more formal definition of close. So we're going to do that. There's these little Greek letters that come up all the time in proofs. And they are basically the way that I show small distances. Vanishingly small distances. And it's called epsilon delta. So we're talking about epsilon delta proof. And oh shit, that sounds like I'm about to give you a root canal. All right, but oh well. So here's the idea. What should it mean for the limit? So let me just write this down. If I wrote this all down, what does that mean?
As x approaches a.
What does f of x do?
I can't remember.
Yeah, you're fine. So as x approaches a, as x gets really close to a, the outputs get really close to L. Is that cool to say? That's basically what we've been saying this whole damn time, you guys. Yes? No? Yes? Okay. So we're going to formalize the hell out of this. And I didn't assign like a ton of problems from here. Only like one or two of them have any trickiness to them at all. Once you get it, it's almost too easy. You don't really believe that you're doing it correctly. But at first, it's not going to be easy. So just hold on. So here's the visual of this. I have a better visual on it, and so does the book. The book has a better visual than I could ever do. I basically have the same thing on the paper I'm going to show you. Oh, let me look at this one. This looks a little bit better. All right, so here's a function. Oh, let me turn you around for once. People playing along at home, you can see what's going on. Wow. And that's where the earthquake happened.